Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. What if I told you a single missed document class can cost a company serious money? One team trusted overall accuracy. They never checked per class recall. Their CT scan authorization forms disappeared into a black hole of misclassifications. That's not a horror story. It's a Monday morning if you skip the safeguards. In this video, you'll build the exact classifier that would have stopped it, and I'll show you every governance step that turns a fragile model into a production weapon. A regional health insurer deployed what it thought was a battle-tested image classifier. Within weeks, a substantial number of CT scan authorization requests were misrouted as routine lab orders. The payment delays breached provider contracts and triggered severe financial penalties before anyone noticed the drain. That disaster happened because the team trusted overall accuracy without checking per class recall, never set up a human review gate, and never monitored for drift. Today, you're going to build the classifier that would have stopped it, and we'll walk through every safeguard that turns a fragile model into a production weapon. Here's what you'll be able to do by the end of this video. You'll have a custom classifier with a managed identity, AFA, an automatically assigned identity in Microsoft Entra ID that lets your application authenticate without storing any secrets. An enrichment pipeline using computer vision API, and production monitoring with OpenTelemetry. The insurer's oversight could have triggered a major regulatory fine. In healthcare, a single governance gap often leads to six-figure penalties. The shield you see here is the minimum viable governance for any classification pipeline in production. Skip even one of these, and you're not managing risk. You're just hoping. By the end, you'll have three things: a custom classifier running on Azure that labels form types with high accuracy, tuned for production; a script that enriches those images with generic tags and scene descriptions using the computer vision API. And the whole pipeline will authenticate with managed identity and log every prediction through OpenTelemetry. No keys, no guessing, no blind spots. Here's the blueprint. On the training side, labeled images flow into Azure Custom Vision. You train, publish, and get a model endpoint. On the inference side, a scanned form first hits your custom classifier, which answers, "What kind of document is this?" The prediction then goes to the computer vision API for generic tags, captions, and dense captions. The two services share one secure authentication path, and everything feeds into your downstream logic, whether that's a routing queue or a search index. Quick checkpoint. What metric did that insurer ignore that led to the disaster? Let's test your understanding. You're routing consent forms in a healthcare pipeline. Which metric must you maximize to avoid missing critical documents? The answer is recall, because it measures the fraction of actual consent forms the model correctly identifies. Custom Vision gives you transfer learning, a neural network pre-trained on millions of general images that you fine-tune with your own labeled examples. That base model doesn't know what a prior authorization form looks like. If your training set is tiny, biased toward one lighting condition, or lacks edge cases, like folded, rotated, or half-scanned documents, The fine-tuned model inherits every one of those blind spots. The technology doesn't automate data quality. It amplifies whatever you feed it. So before you trust the model, you have to trust the data. The Computer Vision API is a pre-built analyst. You call it with an image, and it returns generic tags like document, handwriting, or medical equipment. It can generate a caption, a printed form with handwritten notes. But it has no idea that the form is a referral versus a consent form. That's where the custom classifier earns its keep. It answers the specific question, what type of document? The two services are paired. The custom model gives you the business category. The Computer Vision API fills in visual context. Together, they give you a rich metadata layer without training anything else. Quick checkpoint to make sure the roles of the two services are clear before we start coding. Create a virtual environment called cvdemo-venv and activate it. Then install the core Python libraries, requests, the Azure Identity Package for Managed Identity Auth, Pillow for image manipulation, PDF2Image, and PIPDF2 for handling multi-page documents later on, and the current OpenTelemetry exporter for Azure Monitor. This is the stack that carries us from data prep to production monitoring, and it's fully keyless from step 1. Now provision the foundation. Create a resource group to hold everything, then a Cognitive Services multi-service account. In a lab, this single account gives you endpoints for both custom vision and the pre-built Computer Vision API. Production environments typically split them for tighter security, but this simplified setup keeps your learning pipeline clean. Let's confirm you understand the identity-based approach we used for infrastructure. We're building a healthcare document classifier, but real patient forms can't be shared. The solution: generate a batch of synthetic JPEGs, roughly 150 per form type, for prior auth, referral, and consent. The script creates plain forms with a tag header, a few real-world medical keywords, and random line noise to simulate scanner artifacts. The folder structure is the same one you'll use later with real scans, so the pipeline exercises everything end-to-end from day one. Let's double-check the reasoning behind our resource architecture. Before uploading, remember the API limits how many images you can send per call. We slice the list into batches of 64, a safe size that works reliably. Network glitches or rate limiting can still bite, so we wrap it in an exponential back-off loop, 5 retries, waiting 2, 4, 8, 16, then 32 seconds. This same retry pattern will protect your production prediction calls later, so it's good to practice now. Now tie it all together. First, create the 3 tags, prior auth, referral, consent, which return the tag IDs we need for uploading. Then, loop over each tag directory and call our batch upload function. When the script finishes, every labeled image is inside the custom vision project with the correct class. The project is ready for its first training run, and you never once pasted an API key. Quick fundamentals check. We're building a classifier, but what does that actually mean? Before you jump into per-tag metrics, make sure you can define the core task. This is the moment your lab moves from setup to real machine learning. You send a post to the training endpoint with your project ID, grab the iteration ID from the response, then poll every 10 seconds until the status reads completed. No GI, no clicks. One Python script triggers the entire training run. After training finishes, the real evaluation begins. You call the performance endpoint to pull per-tag precision, recall, and average precision. If any tag has much lower recall than the others, That's a red flag. The model is missing that form type frequently, no matter how high the overall accuracy looks. Hunt those gaps, not a single vanity score. A bar chart makes the weakness obvious instantly. Imagine a run where prior auth and referral both show recall above 0.85, but consent sits at 0.45. That means the model misses more than half of real consent documents. When you see a flat bar like that, you know exactly which class needs more training examples. The mistake almost every beginner makes: tweaking learning rates or epochs when the real problem is not enough varied data. If consent recall is weak, add consent forms with different lighting, rotations, handwriting styles. The model can only learn from the patterns you show it, and right now, it's never seen a folded consent form with a coffee stain. Once you've trained, run an automatic audit. Grab every tagged image and its predictions, then flag anywhere the model's best guess doesn't match the label you assigned. Those mismatches are either mislabeled data or confusing examples. Both need your attention. This one script catches errors that manual inspection would miss, just like the insurer's oversight. This blueprint isn't theoretical. Organizations handling high volumes of forms, insurance, healthcare, government, use very similar approaches. Training a custom classification model on Azure and pairing it with computer vision for enrichment. It turns manual sorting into intelligent triage, boosting accuracy and freeing up staff for higher value work. You're building the same foundation right now. Your training resource should never handle live traffic. You spin up a dedicated custom vision prediction resource with this one CLI command. It lives in the same resource group, uses its own endpoint, and lets you scale inference independently. This isolation is what keeps training fast and predictions reliable. Before your model can serve predictions, the managed identity needs permission to access the prediction resource. This one-liner grants the cognitive services user role on the prediction endpoint specifically. Run it after creating the prediction resource and before making any prediction calls. Miss this step and you'll get a 403. Let's lock in why that role assignment is the gatekeeper for inference. The custom model tells you the form type, but what about the content? Handwritten notes, stamps, checkboxes. The pre-built computer vision API can see those. It's a hosted model you call over HTTP. It returns a human-readable caption and region-level dense captions. Pairing custom classification with those pre-built insights gives you a complete understanding of every scanned page, all through the same managed identity. Before any of this works, your managed identity needs permission. This RBAC assignment, Cognitive Services User Role, scoped to your cognitive resource, is what lets the identity call the prediction and analysis APIs without a single key. Run it once per resource and you'll never see a 403 again. This is a confusion matrix drawn as a radial graph. The three nodes are the true classes: prior auth, referral, consent. Edges show what the model predicted. Self-loops are correct predictions. The heavier, the better. But focus on the red edge, consent images predicted as referral. That's a common off-diagonal confusion that can misroute half a department's documents. Consider the war story insurer we mentioned earlier. A pattern like this, consent forms collapsing into referrals, can undermine an entire pipeline and cost real money. A diagram like this lets you spot off-diagonal confusion in 5 seconds before it hits production. 4 lines of code that prevent misroutes, assuming you've already created your custom vision project and have its prediction endpoint ready. When Custom Vision returns a prediction, the top tag comes with a probability between 0 and 1. If that number is below your threshold, many teams start with 0.7. Don't auto-route the document. Send it to a human. In the field, low-confidence predictions that got auto-routed caused serious problems. A threshold of 0.7 catches guesses without creating an unmanageable review queue. Pick the threshold based on your tolerance for mistakes, and treat 0.7 as a starting point, not a fixed rule. Test and tune against your holdout set. Here's the blind spot with a simple threshold. Imagine the top prediction is 0.52. That's below 0.7, so we flag it. Now imagine the top prediction is 0.49 for referral and 0.48 for consent. Both are below 0.7, so a simple threshold catches it. But what if referral is 0.51 and consent is 0.48? That's above a 0.5 threshold and clears it, yet it's still a coin toss. Shannon entropy measures how spread out the probabilities are. This bar chart compares entropy for 3 scenarios. A confident 99% prediction has just 0.08 bits. A near tie like 0.51 versus 0.49 produces almost a full bit, right around 0.999. Set a threshold at 0.8 bits, and you flag both the uncertain and the near tie cases, catching ambiguity. A simple confidence gate misses. The War Story CT forms had probabilities near 0.45 for both classes. Entropy would have flagged every single one, even if the top probability had technically cleared 0.7. 5 lines of code, and it catches the cases that cost real money. Once your project is set up and you have its project ID, you can build a regression test suite. The insurer didn't just train once, they trained, deployed, and stopped measuring. Here's the pattern that prevents that. After every retraining run, execute your holdout test set and assert that recall for every critical tag is greater than or equal to a stored baseline. If consent recall drops meaningfully from the stored baseline, the assertion fails and the pipeline stops. No deployment happens. Store the baseline per tag in a config file or database so it persists. Later in the series, we'll integrate this into a GitHub Actions workflow that runs automatically on every pull request. For now, know that a regression test suite is not a nice-to-have. It's the difference between a model that improves and a model that silently rots. Time for a recall check. Your model returns probabilities that are nearly equal, say 0.55 and 0.45. A simple threshold might let it pass, but the ambiguity still risks a wrong decision. How do you catch it? Pause and answer before the reveal. The answer. You compute the Shannon entropy of the probability distribution. A near tie produces high entropy, which can exceed a guardrail threshold you set. So your automation can route it to human review, even if the top score clears a basic confidence threshold. With your custom vision project created and the prediction endpoint configured, you can instrument every call. A model in production without logging is a black box. When the insurer's predictions started drifting, no one knew for weeks because no one was watching. Here's the fix. Instrument every prediction call with OpenTelemetry and ship structured logs to application insights. The package is Azure Monitor OpenTelemetry, not the old deprecated OpenCensus library. You set up a logger provider, attach the Azure Monitor exporter, and then log each prediction with custom dimensions, the predicted tag, and the confidence score. That's it. Now you can query the traces table in Log Analytics to track confidence drift per class over time. If the median confidence for consent drops 10% in a week, you retrain, before the business notices. The Cognitive Services API is a cloud service, and cloud services hiccup. You'll get a 429 when you hit the rate limit, or a 503 when the service is temporarily overloaded. Without a retry policy, one transient error kills your batch. With this 6-line adapter, the request session automatically retries up to 5 times with exponential backoff. 2 seconds, then 4, then 8, up to 32. Notice the status force list. It only retries on 429, 503, and 504. A 401 or 403 is an authentication failure. Retrying won't fix it. This pattern should wrap every production call to any Azure AI service. Checkpoint. Production hardening steps. Logging without alerting is like a smoke detector with no battery. Here's how to wire it up. In the Azure portal, go to Monitor, create a new alert rule, and scope it to your Application Insights resource. The condition is a custom log search. This KQL query counts failed requests from your Classifier app over a 5-minute window. If more than 10 failures occur in that window, the alert fires. Attach an action group that emails the on-call engineer. That's the difference between finding out about a production outage when your phone buzzes and finding out when the business asks why nothing's been processed since Tuesday. 3 failures that hit real production pipelines, and you can prevent all of them before they happen. First, training fails with training failed error or stalls for hours. The root cause is almost always too few images per tag. You need enough training examples for a reliable multi-class model, or near-identical images across classes confusing the trainer. Fix. Add more varied examples and run the audit script from earlier in the chapter. Second, you hit an iteration storage limit. Projects often have a maximum number of stored iterations. When you retrain frequently, you can fill that up over time. Fix. Delete old unpublished iterations via the REST API and keep only the last 3 successful ones plus the one currently in production. Third, you try to export the model for offline use and it fails. Not all domains support export. You must train with the compact domain from the start, like General Compact. Compact domains trade a little accuracy for a smaller, exportable model. Pick your domain before you upload the first image. These aren't edge cases. They're the first 3 things that break when a prototype becomes a pipeline. Let's test whether you'd catch degrading recall before it hits production. Let's lock in what you actually built. First, a custom image classifier that distinguishes 3 form types with strong, consistent per-tag recall, deployed behind a REST endpoint you control. You trained it, published it, and called it with a test image, all without clicking through a portal. Second, every single API call in this pipeline, custom vision training, prediction, computer vision analysis, authenticates through managed identity. There is not one API key committed anywhere in your codebase. That means nothing to rotate, nothing to leak. Third, you didn't just train a model and walk away. You wired up OpenTelemetry logging. So every prediction's top tag and confidence lands in Application Insights. You added a retry policy for transient failures. And you built a regression test suite that will catch degrading recall before it reaches production. These 3 things together, a deployed classifier, keyless authentication, and production observability, are what separate a lab project from something an employer trusts with millions of documents a year. Final checkpoint. A developer just committed your prediction key to a public repo. You revoked it. And now 20 production containers are dead in the water with 401 errors, and you can't restart them for 6 hours. What's your move? Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.